Question number 2. Figure number 3 shows a battery operated remote control car. 2.1 is an A1 question, and this question is from energy transfer in a system. The car battery contains a store of energy. As the car moves, energy from one store is transferred to another store. Describe how different stores of energy change as car moves. You can see here from the figure number 3, a toy car is moving, so definitely it has kinetic energy. But this kinetic energy is coming by the chemical energy which is stored in the battery of the car. So the chemical energy of the car battery is decreasing, whereas the internal energy or kinetic energy and potential energy of the surrounding environment is increasing. Students usually make a mistake here. They just try to write that chemical energy store is transferred into kinetic energy store of the car, but it is an insufficient information. Let's see the model answer. The battery has chemical energy stored, that is the extra information which student must remember. As the car is moving, the chemical energy of the battery decreases. The internal energy means the kinetic energy and the potential energy of the surrounding air is increasing. This information can help the student to understand the chemical energy store is changing into kinetic energy store, but this is irrelevant to this question. The car has a top speed of 12 meters per second and a mass of 800 grams. 2.2 is an AO1 question, and this question is from the topic of changes in energy. Write down the equation that links kinetic energy, mass, and speed of the car. It is an AO1 question. The student must remember the equation of kinetic energy. That is EK, that is equal to 0.5 into mass of the car into square of velocity of the car. Or student can write another way. EK, that is equal to half time mass into square of velocity of the car. Two point three is an AO2 question, and this question is again from the topic of changes in energy. Calculate the maximum kinetic energy of the car. We are already given the speed of the car, which is 12 meters per second. The mass is given 800 grams. We need to convert grams into kilograms by dividing by 1000, because 1 kilogram that is equal to 1000 grams. So we will get 0.8 kilogram. We need to find the kinetic energy. We will use the above equation, Ek, that is equal to 0.5 mv square, and we can find the kinetic energy of the car. Let's see the model answer. We have the equation kinetic energy is equal to 0.5 mv square. The mass is given 0.8 kilogram. We're going to substitute here. The velocity is given. We're going to substitute here, and we need to scale it. And we will get the answer by using the calculator. Kinetic energy is equal to 57.6 joules. And the Mach distribution is given here. 2.4 is an AO2 question. Explain why having more efficient motor increases the top speed of the car. This question is from the topic of energy transfer in a system. If the car has more efficient motor, it means that less energy is wasted in the form of kinetic energy or potential energy of the surrounding. Let's see the model answer. If the car has more efficient motor, then less energy is wasted to the surrounding air. High proportion of chemical energy is used to convert into kinetic energy of the car. And the Mach distribution is given along the points. 2.5 is an AO3 question. A driver wishes to buy a new car, and this question is from the topic of global energy resources. Table number 1 gives some data about an electric car and one with a petrol car. You can see from here the table number 1, the electric car information and the prices, average lifetime, and the cost is given. Along with that, the petrol engine car is also given here. Which car would be the most economic over its 12 years lifetime. Use the data from table number 1 to support your answer. You should include the difference in the cost in your answer. So we have two kind of cars. One is an electric car and other is petrol engine car. The initial cost is also given here for both of them. The running cost per year is given for both of the cars and the time is same, that is 12 years for both of the cars. We need to find which car is more economical after 12 years. Let's see the model answer. We know that the running cost per year is 250 and for 12 years for the electric car is 3000. The total cost of the car after 12 years is, that is 3000 plus the initial cost which is 27,000. The total cost after 12 years is 30,000 pounds. The running cost for the petrol car is 2000 per year. The 2000 into 12 is 24,000, whereas initial cost for the car is 15,000. Therefore, the total cost of the car after 12 years is 39,000. We can see that the total cost for the electric car is 30,000 and that of the petrol car is 39,000. So the electric car is saving 9,000 pounds in 12 years. If we look back here, the initial cost for both of the car, that is 27,000 for electric car and the petrol car is 15,000. Students make a mistake by saying this thing that petrol car is more economical because the initial cost is low as compared to electric car. But they usually ignore the running cost per year. So we will see that the electric car is cheaper over the 12 years. There is other method given for both of them. We will spread the cost over 12 years, that is 27,000 divided by 12 plus the running cost per year, that is 250. The overall, the annual cost is 2,500 pound for electric car. Similarly, we can find for the petrol car also. The petrol car has a cost of 15,000, so we can spread the cost over 12 years. That is 15,000 divided by 12. It is 1,250 pound plus the running cost per year. So overall, it is 3,250 pound. So this is another method we can compare. The electric car is 750 pound cheaper than the petrol car. But I will advise the student to take the first method which is given here, which is more easy for the student instead of using the annual method.